what you're going to find is there's 3 questions, just like all the other standards, and they can be in different orders, but typically what you'll find is there's a question on solubility. And when you do that, they'll ask you to do things like, well, I haven't written it here, but write an equation to show solubility. Now, solubility is just dissolving, okay, so I'll show you how to do dissolving equations today. The next thing you'll get asked to do is write a Ks expression and then calculate the Ks, and I'll explain what Ks is today. And then they'll ask you to calculate solubility. So that's there's 2 calculations in here. There's calculate Ks, and then there's calculate solubility. And students often get them mixed up, so I'm going to be really like black and white about that's that one, that's that one. So, and then that is like the first third of the standard. Species in solution is knowing that when the species dissolve, sometimes they form an acidic solution or alkali solution, and if you have a good memory, ethanoic acid, it firstly dissolves, and then the ethanoate ions react with water, and that's where you get your hydroniums. I'll take you right through all of that, assuming that you don't know any of it from level 2, okay? So, but this is deemed to be quite tricky, but you'll just have to, see what you can do there. Okay, and then lastly, you've got the acids and base section. Now, the pH calculations we do this year are for weak acids and weak bases, so they are a bit trickier. We draw out titration curves, and we don't do titrations though, and there's calculations at various points in the curve, and one of those points in the curve is a buffer region, and there's buffer calculations. So there's actually quite a lot of calculations in this standard. Okay, so that's what we're going to be going for, and that's a typo because that should be 5 credits. It's a big standard, sorry about that. Okay, so let's move to the saturated solutions. So what you're going to find is we're going to have a beaker, and you'll put a solid in it, and it'll be ionic, okay? So as you pour it in, the ions will dissolve, and you don't need to be able to do that explanation of water attracting to the ions and the intermolecular forces being overcome. Like, that's all the level 2 component. You simply need to understand that as you put the solid in, what first happens is ions come out into solution, okay? There will be a point at which you meet saturation, and that means no more solid will actually dissolve, and so ions in the solution will actually come back and join up with the solid. So that's the difference between a solution and a saturated solution. It means that the ions will actually come back and join up with the solid. Meanwhile, ions in the solid will go back into solution. Now, when the rate of the ions going into solution is the same as the ions coming back to the solid, that is equilibrium, okay? And that's what happens with a saturated solution. You will get an equilibrium. Now, visually, you won't get to see it, okay? So the macroscopic properties, macroscopic is what you see, the big picture. You won't see ions coming out and ions going in, but microscopically, if you could zoom in and see those ions, that's what's happening. So so that's the understanding, and then you're going to be asked to write equations to show that. If you want a really formal definition, not that it's asked, but it's a saturated solutions where no more solute, remember solute is the word for solid, will dissolve into, and it's the solvent to form the solution. But yeah, those 3 words, solute, solvent, and solution, aren't that important. Okay, so going into what you're going to be first asked to do, and that is write an equation to show the dissolving process. Sometimes they might use this word here, dissolution. It just means dissolving. To do this, you always start with the solid first. So if I'm using this one as my example, what you're going to have is you write down the solid, MgO. State symbols are really important. Okay, so there you go, must show state symbols. We don't show water. We have equilibrium arrows, and then we just break it into the ions. Now you will have a periodic table, so if you've forgotten charges on your ions, you'll be able to go to your periodic table. Typically that won't be a stumbling block if you don't know the charges on your ions. And then you've got your O2 minus. Okay, so that is typically the first question. And I've got your NZRC papers ready for you today, so you can give those a go. So what I've got here is just another example. So you put your solid in, and then some of the ions will go into solution, and when you reach a certain point, so the saturation point, then the ions will start coming back to the solid. It's important that you understand this is going to be an equilibrium, because like you just keep putting the solid in until dissolving stops, and that's when the equilibrium's set up. Okay, so this here is another example. So magnesium chloride, you've got your solid state symbol, equilibrium arrows, you've got your two ions. Be quite vigilant. If you've got two here, you'll get your two chloride ions, and that's going to become important in a minute. And it's the equilibrium is between ions that are in the solid coming out to the solution, and those in the solution going back to the solid. Any problems with that? Okay, so if I just show you, we are quite limited to the ions that they can use, or the ratio of the ions, and you will see this in the side pad, and you'll see it in like mark schedules, and you'll be like, what does it mean? An A-B type is meaning the ratios. A and B are not elements, okay? So an example of this is if you had sodium chloride. Now you don't need to write any of this down because we're going to do some examples in the side pad shortly. So you've got sodium chloride, and when it dissolves, okay, you get one sodium ion, aqueous, and one chloride ion. Okay, so where the AB type comes from is the fact that there's one sodium, one chloride, so hence the ions, it's a 1-to-1 ratio. This becomes important shortly. The other type you'll get is, for example, Na2O. Okay, so what you're going to get in this type is now there's two cations, see the two there? So that's the two sodium ions. So you'll notice that you get the big coefficient 2 there, and you get the O2 minus. And you can probably guess what this one's going to be, okay? So an example would be, for example, calcium chloride. Okay, so again, start with the solid, goes into solution, got the calcium ions, and got the two chloride ions. Okay, any problems with that? Good news is you won't get an A-B3 type, like a 1-to-3 or a 3-to-1 ratio. However, up here you could have MgO. It's not to say that it's going to be a +1 charge. This would also be an AB type. Okay, it's the fact that you've got one cation to one anion. All good with that? Okay, so that is the first type of question you get. The second type of question you'll get asked to do is to write a equilibrium expression. Do you remember from last year what equilibrium expressions, how they worked? Do you remember the symbols that we used for equilibrium expressions? Okay, it was Kc last year, and it was always the concentration of the products over the concentration of the reactants. Does that bring back memories?
Yeah.
Now there was a couple of rules, okay, from last year that you weren't allowed to put into the expression. Do you remember what they were?
Water.
No water. And we noticed that we don't even put water into these equations, and that's important. Okay, the fact that they're dissolving is showing the fact that you've got your solid going into an aqueous solution. So the water concentration would stay relatively constant, and that's why you don't put the waters in here. And you certainly wouldn't put water into this equation. There was one other thing that you didn't put in this. No solids.
Oh, okay. Sure.
So this year, you're still going to be doing equilibrium equilibrium expressions, okay, which is what that is, but we are going to call them the KS expression. So notice the C has now changed to an S, and it's called a KS expression. So, what do you think the S stands for?
Solubility.
Solubility. So this one here would be the concentration of your sodium ions multiplied by the concentration of your chloride ions. Now remember, it's always products over reactants, but what have you got on your reactant side?
A solid.
A solid. And therefore, this year you're going to find that they only ever have a top line. They don't ever get divided by.
So do we do KC?
Well, no. So C stood for constant, and this year when like being more specific, and we're going to only look at solubility.
Yeah.
So this year you're only ever going to be calling them KS, and in the exam they only ever refer to KS. If you by chance put a C there because you're just being, you know, a little bit lackadaisy, that's fine. It's still true. It's just not specific. Yeah. So that would be okay. But KS expressions are equilibrium expressions. This one here, you would do your sodium concentration. What do you remember from last year about coefficients?
They go to power.
They go to the power, don't they? And so the 2 there would become sodium to the power of 2. And then you've got your O2 minus concentration. And then this one here would be KS, which is the calcium concentration times your chloride concentration squared. These are the only 3 that you're going to get this year. You're not, as I said earlier, you're not going to get a 1 to 3 type, so you'd never get to the power of 3, which is quite good for when we go into the calculations. It's kept very basic and simple. And already at this stage, I know students struggle writing the case expression because they just, it's sort of it becomes quite overwhelming. But straightforward, okay, from last year, no water, no solids, and just put to the power of whatever the coefficient is, and your coefficients will only ever be 1s or 2s, okay? So that's the second thing that you'll get asked to do. So I've got a example. So if you're going to watch this again, or yeah, I've just got some other examples there. Don't worry about this stuff just yet. I'm going to get there shortly. Okay, so square brackets stands for concentration, and the concentration needs to be in moles per litre. The problem that you will find is every now and then they give you grams per litre, and I'll show you how you do the conversion. And I've said there, solids and water are always omitted. Okay, leave them out. So, if you want to pause that video there, Selena. 2:43. Okay, so, are we recording?
Yeah.
Thank you. Okay, so this is going to be potentially the third thing that you're going to get in an exam question, all right? And they will ask you to calculate a value for KS, and what they're going to do is they're going to give you the solubility. Okay, so as I say, on page 243 in the side pad, I'm going to do it with you so that you can see how it works. So I'll explain it using this example on page 243. So this is number 1. The solubility of calcium sulfate. So I'm going to give myself the equation because that helps me understand what I'm doing. I've got calcium ions and I've got sulfate ions. And they are asking us to calculate the solubility product of the calcium sulfate. So to do that, I'd have to have the expression, okay, the K solubility product expression. So I need the concentration of my calcium ions, and I need my concentration of my sulfate ions. If I know those two values, all I'm going to do is multiply them together, and I'm going to get an answer. They do give us information. They have told us that that is the solubility. So solubility has a symbol S, although sometimes I've used in the past the letter X. It just means how much of it dissolves. And we know that it's 2.4 grams dissolves in a litre. So if I had a beaker with 1 litre of water in it, and I put in a mass of calcium sulfate, what you're going to find is the number of calcium ions and the number of sulfate ions that dissolve is 2.4 grams in that litre. Okay, so it's telling us how much of the ions dissolve. It's not telling us like how much calcium sulfate was put in, like it could be 10 grams. If you did, you just deduct off 2.4 and that's the ions in solution, and then you could work out, but that's not the type of question you get. So we need to know the concentration of the calcium ions, and we've been told, or we can see, for every one of these that dissolves, you get 1 calcium. So if you get told 2.4 grams of this dissolves, how many calciums would you get? 2.40 grams in a litre. Okay, that's how much of it dissolves, and that's the calciums. How much sulfate would you get? Now be really careful. If you put a calcium sulfate in, it gives you a calcium and a sulfate. So you would also have 2.4 grams of sulfate ions, because the calcium sulfate consists of a calcium and a sulfate, and some students think that you'd get 1.2 grams of calcium and 1.2 grams of sulfate, but that's not what it is. Okay, so that's going down the wrong path. So calcium sulfate dissolves, and it would give you, this is the calciums and this would be the sulfates. Following me so far? Okay, so it's a 1-to-1 ratio. So their concentrations are the same. Now, I've written the tip down here. We need to use, when it's got square brackets, moles per litre, but they've given it to us in grams per litre. So to convert, what you need to do is divide by the molar mass of the calcium sulfate. So I'll just rub that part off and divide that by 136 grams per mole. And do I have a calculator? I'll just get my numbers out.
How do you know that it's 136?
136.
Oh, it's right there.
Yeah, they will provide you the molar mass. Okay, so that is 0.0176 moles per litre. So the concentration of the calciums is 0.176 moles per litre. The concentration of the sulfate is 0.0176 moles per litre. This is going to be something that you might want to go back and write on that resource sheet. It's not going to be given to you on the day, but it's quite a common trick, and it'll cause some students to not be able to go forward that conversion. You just divide by the molar mass. Okay, so now all we're going to be doing is taking the concentration, and typically we don't use square brackets. We now put in just the value in rounded brackets. If you keep square brackets, that's fine. And the value, if you do the calculation in a calculator, is 3.11 times 10 to the minus 4. And some really good news, and I've not written it down, KS does not have units, no units.
Is it 366?
Yeah.
So,
To be more specific, it is always the number of significant figures they give you in the question, you retain and keep consistent. So they've given it to 3, and that's why you give it to 3. So that's, rather than just like learn, oh, it's always 3, it's actually, you replicate the level that they give you as the actual